Hi everybody. Today is Tuesday, 19th of March. Let's continue with the lab EL228. But for this one, we're going to talk about the frequency response of our amplifier circuit. And in this case, what we're going to do is we're going to talk about the common collector circuit. Okay, so what we're going to do is that we're going to draw the circuit, make connection of circuits, and then do a simulation and analyze the plot. Okay, we're going to do the same thing. We're going to use the LTSPICE for simulation, and then after that we're going to use the LTSPICE IV to compare, and then I will explain about what's going on in the circuit for common collector circuit as their amplifier circuit. Okay, let's go to first go to LTSPICE. I'll start open our schematic, and then let's draw the circuit together. Okay, hold on a second. Alright, so let's blow this up a little bit. Okay, let's see the main NPN transistor we're going to use for amplifying our circuit. Let's see, look for something, Control G, and let's use just like Q2N222. So I'll place this one, and then right click to stop placing the component, and then I need to like phi R. Okay, so Control G and R, and then this is the one, and then Control G R. I need another 4. So let's rotate, Control R, and make copy, Control C, and then Control V. This is going to be 2, 3, 4. Okay, I totally have 4 resistors. And then I also the input voltage. In this case, I'm going to use the V psi because we're going to analyze the AC signal analysis, and we're going to set up the AC voltage later. Control G. I also need ground A, G, and G, and I also need capacitor, Control C, Control G, sorry, and then I use the capacitor, and then I need to bias the transistor with the DC voltage, so I put like VSRC, that is the source voltage, and then let's do this one for 15 volt. Go to attribute, and I put DC to be 15 volt. Okay, keep in mind that what we're going to do now is we're going to do common collector circuit as the amplifier circuit. Okay, let's rearrange the circuit. I need R key, and I'll set it R right here, and then R right here, connected to collector, and then let's make connections. Control W here, connect their input voltage to the circuit, and also connect to NPN transistor. connect it to ground, and then this one also actually I need another resistor right here to emitter and connect to ground. Control W. Or it will take for a while, but it's coming soon. Let's put this right here. Move this one. Alright, and then the last one. Control W or make the last connection. Alright. Now the next thing is we're going to do is let's set the VSI as the input voltage. So I'm gonna put just like only 1 volt AC. I don't need offset, DC offset. So I set that one to be 0, and then also you need to put in 1 volt for amplitude, and the frequency let's make it to 100 Hertz as usual. You can put any number, doesn't matter. Alright, and now let's change this one R as in the lab. So put this one to be your 10K. Sub attribute, click OK, and for capacitor I'm going to put 1 microfarad. So use this one to be 1U. Sub attribute, and this guy's to be your 240K. Put sub attribute, click OK. Alright, let's move this one a little bit. And this one is going to be your 4.3K. 4.3K. And then also this one I did put 15 volt, right? The attribute. Okay, that's 15 volt. And then this one is going to be 470K ohms. Almost done. Sub attribute, click OK, and this guy make it to 33K. Attribute. So for this one 33K. Sub attribute. This one a little bit, and I also need to specify this one to be V out as the reference. So I put this one as label and then V out. Okay. Now you already have a complete common collector circuit. I actually don't need to rearrange the circuit, but just to look better. So I move this one a little bit. Move this one a little bit. Alright, just make it smaller. You can do this one. Okay. So now we ready to do simulation, but first we need to go to setup for the frequency response. What we're going to do? We go to the main menu, analysis. Go to setup, and since you want to do a frequency response, you go to AC sweep. Let's make this one to be 10 meg MVG. Start frequency is from 1, total point is 101, and AC sweep type need to be decade because it's going to start from 10 Hertz to 10 megahertz. Alright, I'll click OK. That's about it. I'll close this one. Before I do simulation, you need to save this. And then I put this one as the, let's say, become a common collector circuit. let's try to do a simulation. So anything missing? No. And then you're going to have a plot window pop up. Have some problems. Retire. Let's see. Okay, I already have plot. And thus you can see here the simulation. You're going to sweep the frequency from 10 Hertz to 10 megahertz. And then what you need to do is need to add plot. And what we're looking for is the gain of the frequency response, right? I'm going to put in the unit of dB and V out divided by V in, since V in is the only 1 volt. So I'm not going to divide it by V1 or V source, just right here. This is your V input. Actually it's the V1. Alright, and then you're ready to get the plot. So this is your frequency response of a common collector circuit. Let's see, I'm going to make this one the width of the plot. It's getting bigger to so easy for you to see. Alright, so this one is the actually amplifier circuit. You can see that this is the gain in the unit of dB, or equal to 20 log of V out over V in, and that's this one is about what, like 16 dB, right? This is in the unit of dB already. So you can also find the cutoff frequency. So you can take this one, drop down to 3 dB, and then you can find that the cutoff frequency. Actually, what it can do is the cutoff frequency, or you can get the cursor right here, left click, and then you go to the right click for another cursor, and you try to make this one the difference. This is the X and Y coordinate. This is delta X and this is delta Y. And you need delta Y to be let's see, I'm going to control this one to be 3 dB, right? The different. So put the right. So this is about 9, but we're looking for oops, just have some difficulty to control cursor. So this one is about 3. You look at this one. You move this one a little bit. So this is about 2.95, which is what we're looking for is the drop down 3 dB. So at this one, for A2, this is your X and Y coordinate, and this one is the frequency, and this is the gain. Don't get confused. So the frequency or the bandwidth is just about 618K. Okay, that's your cutoff frequency. Now look back into the circuit. What you can see is that let's just take a look at only the voltage on each node, so you can also make yourself more understand. So I go to display result on schematic. I'm going to enable only the voltage display. So basically this is becomes 0 because it's the average of sinusoidal input signal. So the average turn to be 0. And this one you have the bias voltage for the transistor. Okay, so we still have like 15 volt. And this one is the, you have a very small voltage equal to the ground. That's the 843 millivolt. Okay, and then let's take a look at the current. So I'm going to enable current display, and then turn off the voltage display. As you can see that you can have the current flowing into the circuit. Actually, sorry, let's get back to the voltage display again. So I'll turn off. So you can see here, this is the voltage difference between the base voltage and the emitter, or VBE. You can go to Microsoft Excel. That's how your NPN transistor is going to turn on. So your VBE is approximate about 0.7, right? Okay. So let's do the math. So that's equal to I'm going to find VBE. So VBE is what? 1.503, and then you minus the 843.88 and E negative 3. That's mean a millivolt. So it's turned out to be about 0.659. So that's become when the transistor is turned on, the voltage difference between the base and emitter, or VBE, is going to be about 0.659 volt. Okay. Now let's go to take a look at the current, and let's turn off the voltage display. You can see that the way you look at you have the collected current is about 1.785 milliamp, and then this is your base current. Okay, get into the transistor. That's about 10.69 microamp, and also you can see that this is your emitter current. That's about 1.796 milliamp, and you can find the beta, or the gain, and you know that your IC equal to beta IB. You want to find a beta, you simply divide it IC equal to beta IC, right? IC equal to beta IB. So you want to find beta, you simply divide the collected current by the base current, or equal to 1.75. Okay, let's do the math together. So your beta is actually 1.785 milli. So I'm going to put E negative 3 divided by the base current, which is the 10.69 microamp. That's the negative 6, right? So this is going to be your beta. It's about 166.9, or just about 167, or from the relation IC equal to beta IB, where beta is the gain of the transistor. Okay, and that's about it. What you get from your circuit. Okay, so this is your amplifier circuit, or using a common collector circuit. Now let's move to our LTSPICE. You go to new schematic, and then let's draw the circuit again, just like what you have right here. Okay, let's minimize so you can see better. We can follow this one. Going to be very quick. Alright, so let's get the graph first. It's going to be big one, and then you have our C, right? Let's get R first. That's difficult. So let's make a rotation of your R, and then you need another for R. So you have this one, 1, 2, 3, 4. Left click to place and right click to stop placing. And then you need what, the voltage source, right? So I'll go to the component icon and then go to voltage. You click OK to place, and you also need the bias voltage for the transistor. And also you need C, capacitor. Let's rotate this one for C. Alright. And what else you need? You need a transistor, right? So you go to NPN transistor, just right here. You click OK. Left click to place, then right click to stop placing. Okay, let's go to the NPN transistor. What we're going to use is the 2N3904. So you make a right click, and then you pick new transistor. So you get 2N3904. You click OK. So this is your transistor that we're going to use. And let's set up this one to be your DC value, the bias voltage for the transistor to be like 15 volt. Click OK. And now you do circuit connection. And this one you need a sinusoidal, right? Voltage source, you go to advanced and then use small signal analysis. So I put 1 volt peak to peak. Okay, P and P. The phase difference is 0, so I put 0 here. Okay. Alright, so they have a AC input signal for peak to peak. Okay, let's do the circuit connection. You go to edit, and then you go to move. I'll move this one, and I'll move this one. Okay, and then you move this one, make connection to C and your transistor. And let's take this one out. Okay, to the right. And then you need the connection just right here. And then you also need R. Oops. Looked like before this I did something wrong. That's okay. We get back later. And then this you have our C connected to our collector, and you also RE connect to emitter. Let's move this one down a little bit. Now you make connection wire, or connect the input voltage to your resistor, and then wire. You have this one, C and transistor, and then R. So collector, resistor, emitter, resistor, and then you connect this one to the ground, and also we do connection. Oops, right. Okay, let's do the rest. And then connect this one to the bias voltage, and also this one connect to the ground, and you're done. Okay, and then I'll reset this one to be 15 volt, right? We did before, just double check. And this is the UV side AC 1 volt peak to peak. Let's cut this one. Okay, and then now set up your resistor. This one is what, 10K. You click OK. Sorry. and then this one 240k, and the other R is this one is the 4.3k. Okay, and then this guy is the 450 ohms, and this guy is the 33k ohms. Okay, and the last one is C. Put is the 1 microfarad, so it's 1 U. Okay, click OK. And also I need reference this one as the V out, right? So I'm going to put a label on it to be V out. Let's put it just right here. Okay, that's your V out. And then now you're ready to do the plot. Okay, make sure everything alright. So you go to main or edit, and then you go to PSpice analysis. You go to AC analysis. The type of sweep is octave. Number of point per octave, you can put like 100, whatever. Start frequency is 10, and your stop frequency is 10 megahertz, right? Heavy G. Click OK, and you place, AC. This is a octave. Start from 10 hertz to 10 megahertz. Okay, in case this is, if you want to change this one, is the actually I need to be a decade. So I change this one. You can go back to edit. Simply right click of your mouse. Okay. Alright, now let's do the simulation. You go to run. Just running. Is your common collector circuit, and then you're going to have the plot window pop up, and you go to plot setting. You get trace, right? And then what you're looking for is actually you want dB, but we can come back to take a look at that later on. V out, you don't have this V out as we did before. You want to check if where's your node, right? I somehow have some problem with the label of the reference. So what you can do is that you can go to edit, and then you go to view, and then you go to PSpice netlist. Okay, so actually your V out is in what? You take a look at this one. Okay, hold on a second. I'll be back quick. Okay, as you take a look for this one, let's see, this is your V out, and this is your R4. You take a look at your R4. It's connected between N001 and N002. So you might think about this one as the N002. The node. This is 4.3K, right? In R2, this is the connect that you want to confirm. Connect between the node N001 and N004. So this is probably become N001 because it's also connected to R4. So let's take a look at N002 to get for the plot. Okay, let's go to the plot. So you want plot setting and add trace. So this is the V in 002. Click OK. So this one is the unit of dB to gain. So this is your plot. The frequency response of your common collector circuit. And in the lab, they ask you to find their gain in the unit of dB at 10k hertz. So you can use your cursor to look for your gain in the unit of dB at 10k. So I'm not going to explain this one. You'll probably be able to do this by yourself. And also asking for the phase difference at 10k hertz. And also ask for your bandwidth. Your bandwidth, just like I explained before, you drop down 3 dB and you can find the cutoff frequency, or that's the bandwidth. Okay. And then also ask you to do the circuit at what 75 degree. So just change that one to 75 degree instead of room temperature, or 27 degree. Okay, now as I mentioned that a student need to do the circuit at 75 degree, looking for the gain in the unit of decibel at 10k, and also the phase difference at 10k. Well, let's see, you want to switch the operating temperature from 27 degree to 75 degree, right? So what you need to do, you go to the main menu and PSpice directive, and now you can type your command for the temperature, so to be 75, so .temp, that's the represent the temperature. So you put like 75, you click OK, and you can drop down or temp 75 just right here, and then you can do your simulation again, and go to the plot, and you can find the gain, okay, in the unit of dB at the 10k. So if you go to this one, let's kill this one, kill this guy. Okay, let's start this one over again to do a simulation at 75 degree. You can go to VR plot. Okay, it's take for a while, and kill this one, and then you go to plot setting, address, and that's the V in 002, right? Okay, you can also take the number into your report. Alright, that's all about using LTSPICE IV for your amplifier circuit or common collector circuit. Now let's get back. Okay, I did something right, just right here. Well, from our PSpice, you can see here, this is the current display. You can find also find the relation. Okay, that's the IE equal to IB plus IC. You can do the math, just to check whether IE equal to IB plus IC or not. Okay, let's start. This is your IC, right? It's the 1.785 milliamp, and this is your IB, and this is your IE. Sorry, IE equal to IC plus IB, right? So let's see if 1.769 milliamp will be equal to 1.75 milliamp plus 10.69 microamp or not. So let's put the 10.69 microamp, that's the E to -6, and you also plus IC, this is the 1.785, E -3. Alright, so that's pretty much about our 1.76 1.9 96 milliamp. So this has become your RE, which is equal to RB plus IC. So PSpice allow you to check if the relation of the simple relation in the circuit is correct or not. In this case, it's just like what IE equal to IB plus IC, and IC equal to beta IB. Okay, I'll see you later on. Bye.